Scott in here. All right, we're going to be testing here. We don't start for a little bit. So you guys or gals that are on, just hang in with us. And we're waiting for Scott Brown to come on, test his stuff. So welcome. This will be really good. Scott's right on top of this. So this is great subject matter for him. And you should be aware of AI. It's everywhere. All right, we'll be back in a bit. All right, everyone who's on, there is obviously no sound. We don't start until about 6:45 p.m. Eastern time. So just bear with us. There's nothing wrong with your computer. Thanks. Okay, Scott, so we see your slide. How about your sound? Could you try your good old voice?
Here I come. How's that sound? Can you hear me okay? Hello,
Say that
hello?
again, Scott?
Can you hear me? Let me
Yeah, I
make
can.
sure my,
Yeah,
I'm talking.
I can hear you.
Is
All
the
right.
sound quality level okay?
You could be a little bit louder, but
A little
sounds good.
louder. Okay. All right. I'll bump it up just a hair here. Check.
All right. So we start going over some of the things at about 6:45 our
Okay.
time, so 3 hours behind your good old time. And we'll take it from there. So we're going to be on mute until then.
Okay. All right. I'll check my magic show
Oh,
here.
there you are. Look at that. You're very magical.
Yeah. See, watch my hands, right? Watch my
Hey,
hands, and then
that was a nice
then-
vet you had in the other day.
oh yeah, I still have it here. It's got 40,000 miles on it. This thing is super clean.
Yeah, we used to have a
but-
guy that had the 50th, I guess, edition or the 25 edition, one of them. It was one of the
s-
race car ones. And
Okay.
he had less than 1,000 miles on it.
Oh my God,
He'd
that's a
pull it
sin.
out. I'm like, why do you even have this car?
Right. That's a absolute sin. Why?
Yeah,
Why would you do
exactly.
that?
You got to drive it. Oh man.
Okay. So,
All right. Well, thanks.
so you're going to be handling any questions that come in, I guess, right?
We will.
And,
We'll
we'll see.
we'll look
Okay.
at the questions.
Yes.
Awesome.
All right, sir.
Okay.
Thanks.
I'll be back just at the top of the hour, right?
You got it.
Okay. All right. Thanks.
Thanks. Bye.
Take care. Okay. So I've got a couple of emails to deal with. Hmm.
All right, sound check. We're about 3 minutes out. So bear with us. Okay, a couple of directions for tonight. When Scott's on, if you have questions, type them in the chat. We're about a minute away, not even, about seconds away.
Quarter of, we
We
start our
always
announcement.
start, watch the wires spin. Yeah, you can sit on that side. Thanks. Well, it does, but we always start early. Because we got to go over, got to thank all the sponsors. So Doreen, you need to adjust your camera. I think I'm right in the middle of the slides. Get us both in the shot. Then you can switch to the slides. All right, we're all good.
Hey, you look good.
All right, as good as we can get. Welcome, everyone, to the TST August Roundtable.
Yeah,
I'm G. Trulia,
and I'm Pierre Espo.
and there's better things to do on a hot August night.
On a nice sunny summer day or evening. But
Now,
here we are.
We're real time over here, but of course Scott is out in fake land out there, so he is 3 hours behind us. So it's like still afternoon for him. At any rate, we're going to go over a couple of things here tonight. Put questions in the chat box. Let's go through our sponsor slides and talk about revolutionizing the automotive service and diagnostics, AI, impact on automobiles with Scott Brown. Let me get my clicker here. There we go. So here's what the Scott man's going to speak about. And if you've been on diag.net, you notice they have an AI thing. I was just telling Scott, I don't know, today or yesterday, whatever, about I seen an answer that someone asked a question. I believe it was Robert Kenny, and AI answered him back because no one else had an answer. That's pretty damn cool. Another thing I'd like to say is try to go to 60 Minutes and look at that AI episode they had probably about 3 weeks to a month ago. Here's what Scott's going to cover: power performance, the neutral networks and engine control operations, discovering how automakers are leveraging advanced neutral networks to optimize engine performance and control operations, revolutionizing traditional methodologies. You could do number 2.
Okay. So seeing the future computer, which is really not a computer, but it's a network of computers, right? Computer vision for ADAS, autonomous vehicles, exploring the cutting edge of applications. And this stuff's growing exponentially, right?
Unbelievable.
Of computer vision, supporting perception systems of advanced driver assistance systems again. And the ultimate goal is autonomous vehicles. There's actually more than that, but in our world, that's where it's going.
And some of the autonomous vehicles, it was just a bad crash with a Tesla that went right into first responder vehicles. It didn't operate as designed. So there's still some glitches out there. I mean, that's a bad glitch, but there's many good things AI could do. AI in the hands of technicians, service information, and diagnostics. Remember when we were on the STS board, the BMW glasses with all
Which
the
they never
information?
really developed, but the concept
It was out there.
the concept was that a technician wouldn't have to go look something up because it would be superimposed on his field of vision as he was working on the car. It would actually put an arrow on the bolts he had to take out in the correct order.
Pretty neat. Yeah. That's why if you're a SAE affiliate member, Society of Automotive Engineers, and get a AE magazine, you get to read all about all that good stuff. And here, uncovering the potential of AI to enhance technical support for automotive technicians. Well, again, Diag.net is doing some of that already, streamlining service information and diagnostic process to ensure effective and accurate repairs. And don't we need that in this industry, right?
And things are getting more complicated. So it's, we still got to do more.
Right. You know, the vehicle, forget about your laptop or computer or tablet. Look at what the vehicle has in it. They are a marvel. Okay. And you got to make your customers aware of that. I think now after the pandemic, there's a shortage of us technicians, and us old guys are old. We're getting older. We're going to be out of this game soon.
Life after wrenching, you know.
I did that a long time ago. But that being said, we need so many young guys to step up to the plate, and we need to attract people into this industry. And what's going to attract people? Money. No matter what anyone says, money is going to pull people into this industry. You know, they did a big thing, I think about 3 months ago, where they were looking at people in, you know, education, lawyers, doctors, you know, people that had a college degree to get these big loans to pay off. And there's nothing wrong with education, don't get me wrong, but you can make a lot of money with your hands. A carpenter, a lawyer, a welder, not a lawyer, a welder, a technician. A lawyer's only going to put his hand in your pocket.
Any of those skills, by the way, you know, this is like my soapbox item, but we as a society need to encourage people to do these skilled jobs, these things where you work with your hands, and not allow others to discourage our society.
Right.
We've had this discussion many times, of course. When somebody talks down about all these skills, you know, I like to say, if it wasn't for people like us, those other people who are criticizing us would still be going to an outhouse in the middle of the night and riding a horse.
Yep. And, you know, don't forget this. I did this years back in my kids when they were in grammar school. They had a whole bunch of professional people came in, doctors, lawyers, accountants, and I was the mechanic guy. And I said, you know what? Dr. Gould, who was the principal, and most of the teachers there, they're all here because I work on their car. Mechanics like us, or technicians, we keep America running. Let's not forget that. Without us, if we ever went on strike, they'd be in big trouble. And notice now, people, you know, our prices have gone up, not to talk about price, but our prices have gone up, just like everything. And
Costs have gone up.
yeah, and
Big time.
people don't care. They want their car fixed or the vehicle fixed, and they'll go to a professional and they'll pay that price. So let's thank our sponsors here, Automotive Test Solutions, ATS, great stuff. Dorman is a big sponsor. We'll talk about an event that they have coming up in September. ATS, we always support stuff. We support tons of training, including TST.
And including the fact that he donates his time for this for all these years.
Auto Leap. And let's not forget, I even did it from an ICU bed.
That's right. That's dedication, or Maybe it's
The sh-
insanity. We're
The
not
show
sure.
had to go on. Auto Leap, good software. We use it here in my shop. Whirlpack and CarQuest CTI and WTI. They have their big, let's give them a plug. WTI has their big training event coming up in 2024. So get in touch with your Whirlpack or CarQuest or Advanced person and try to get in. That will be in Memphis, I believe. Napa, we use a lot of that stuff. AirSep, great stuff from AirSep. If you're putting in a new compressor, you may have some issues with a lot of debris that was in there. They got little filters, they got line splice kits. They have, if you got sealant in there, you should be checking with an identifier for sealant.
Every car.
And we get a lot of that because people go get that can, Pierre. You know,
Yeah.
it's going to fix my air
Oh,
conditioner.
yeah,
It
it's
got
gonna fix
glue in
it. And the system's empty and it has a big hole.
But
So-
epoxy, the epoxy is great.
Right.
So they do a good job. Run Right, our friends at Run Right. They always, we just did a couple of P0 420, 430s. Using their stuff in a drip method works well. We have about a 90-something% rate of P0, 420, and 30 going bye-bye. Works good. MCA, Bacharach, Neutronics. This is the place where you can get the sealant detector. It's about 300 or 350.
And the refrigerant detector, which is a lot more, but if you're not doing this, you're contaminating your supply or ruining your machine.
Yeah, it's air condition aids.
Yeah.
You don't know, right? You wouldn't have sex not being protected. Well, when you don't check out what's in an air conditioned system, by the way, it makes you money. You know how much sealant? We do a good job with that. When we check and someone has sealant in it, we take a little video of it.
Yep, that's
know,
it.
we'll
They have to
show
pay
them.
for that.
And say, hey, you got sealant in there. Oh yeah, I put that can in. Well, now it's going to cost you $150 more.
Or worse, if they allowed it to harden up inside every part of the system and they have to buy everything.
That's right. And if you're on R1234YF, you have, with the newer standard, a built-in identifier. Very, very important. The other ones, you still can use these handheld ones for 134A if you don't have it. Opus IVS, well, again, today, we used it on a truck that was hit by lightning. Even though we have the YTech software, we had to call them up because we couldn't find something in this truck and surface information wasn't clear enough. We got support from them. They do a very, very good job. Opus IVS, good stuff.
By the way, a nightmare truck.
Oh, yeah. We won't even go there.
Yeah.
Key making system. We do quite a few keys with this Triton setup here. They're always a sponsor of ours at the big event. Really good stuff. In fact, we just put another big key order in because we do quite a few of them. Key fobs, keep cutting.
People
all
get
that
a
stuff.
used car, they get a car with one key and not a good idea to only have one key for a modern car, right?
No. Flow Dynamics, good equipment from Flow Dynamics, including you're working on a Tesla or an electric vehicle or even maybe a Chevy Volt, and you need to take that heavy battery down. Well, you better have a capable table to do that. These guys make a table. They make some great machines like the sucking machine for oil.
The air-powered vacuum, let's call it, but yeah.
Well,
it's
this
air-powered.
this one's
Oh,
electric.
the electric
It goes faster than an air operated one. Works really well. We have their tranny jack that's super heavy duty and a bunch of other stuff that they make. Good stuff. Launch. Well, I can't say enough about Launch. Launch has a great scan tool. If you've seen a lunch and learn I did recently, I use their sensor and actuator box. Works real good. They have a pretty decent scope in the tool as well. And the scan tool data is really good, easy to update, and a good tool overall. iScan, another great tool. iScan basically is an excellent European tool. And it not only does European real well, it does Asian super good. You could also connect it to factory software. I had a BMW 7 Series electrified vehicle, a hybrid vehicle, and I didn't have an ICOM. Well, you think you can use a J2534. It wouldn't communicate with this car. And there's certain cars that you need either the ICOM or their hardware will actually turn into an ICOM and mimic it. So these guys also have good tech support. Gary Smith that helps them out, Eric Ehrberg, and a bunch of other guys there, Justin, all good people over there. My buddy, Auto Tech on Wheels. Well, he'll be bouncing around and jumping up and down everywhere. Johnny Boy does a ton of stuff out there with ADAS and programming. Urian, this is a pretty neat tool. I don't know if you've seen it. I have them. I have right behind me.
They basically do, you know, it's a meter, but you tie it to your phone or your tablet or whatever,
Right.
so you can.
And it works, you know, on tablets, Android, Apple, and I think he has it ready for Windows now as well. But it's really a nice setup. There's some neat stuff there, as you can see, with graphing and all this right here. So we give them a plug. Pretty neat. You don't have a scope. Well, you know, this is pretty decent. Ortho is pretty neat. It's a tablet that you speak into to say, hey, I'm working on this 2021 GMC Denali Canyon, and I need how much oil goes in here, and what's the spec of the oil, and what's the torque on the wheels. Pretty neat. They're revamping. It is not currently available. I was going to do a webinar for them, but they are also one of our sponsors. DPF Global, sales and cleaning services, mostly a diesel cleaning thing. I don't know much about them, but they were kind enough to be one of TST sponsors. All Data, well, All Data is one of the things I like going for, because when you look for system description and operation, when you don't know what you're working on,
Which is
you know,
almost
hey,
everything today.
yeah, you got to look it up, right?
Yeah.
RTFI, read the freaking information or you'll be screwed. Identifix and IATN, two good things as well. Mitchell One, we use a lot of that. You want quick specs, you know, you want oil. My guys always do this. They type in the plate number, populates all the stuff. Same with you know, All Data, but this seems to be easier for quick stuff. It's like the abridged version of stuff, but they do a great job. We've done a lot of webinars for Mitchell One, so we thank them for being a TST sponsor as well. Motologic, another good bit of information. In fact, Pierre, myself, and about 15 plus other people, we beta tested this years
When
ago.
it wasn't even out yet.
It wasn't out yet. And they wanted to know what we thought about how the other systems work.
And they
So good
actually
stuff.
listened, by the way, and put a lot of our ideas into their software.
They
which is
did.
kind of cool.
Great stuff. Yeah. Oh, this is a Scott Brown thing here. The this will say when Scott wasn't there, he was teaching, I think, out in Seattle at that time, but he came on and actually announced this to the whole group that Diag.net was coming out. So we had him via the internet. Yep, at the big event. That's correct. So don't forget to sign up there. Industry attends. This is a site that has a whole bunch, it's free, whole bunch of training stuff that is coming up. And let's not forget this here. So Dorman is having a full day Master in the Technology all day training event and trade show. It is Saturday, September 23rd, 8 to 6 p.m. It's at ATC Automotive Training Center down in the Warminster campus in Warminster, PA. And there's 4 instructors. There's myself, Pete Meyer, Kenny Zanders, and Oscar Gomez. Oscar Gomez is doing 2 classes in Spanish. There'll be a bunch of vendors there. You'll see Pierre there and Doreen and some of
All
our
the
guys,
regulars, you know.
because we'll have our booth there.
Yeah, yeah.
And let's not forget here, and we'll just go over this near the end. Here's what we have in the next few months. Adam Roberts. If you were at the big event or ever seen Adam Roberts, a lot of people on the East Coast never heard of Adam Roberts. He did one hell of a job, a very good instructor. He'll be our September instructor on the 16th. More information will be up on the TST website. Dave Hobbs, October the 11th. And again, all these classes. Craig Shippey, another great dude. Craig Shippey, was a Volkswagen Audi expert. He's done a couple of classes for us already. And these are all new classes. These are not something you've seen before. Jeff Zide. Jeff, of course, People love him. He was I think last month's.
Yeah, last month, yeah. And earlier this year too, or late
Yeah.
last year, been
He-
twice in like 8 months.
He's like Pierre on the hotline, and of course he works near the Madman Bernie. So you get to know a lot of different stuff when you're around Bernie. And a new guy, Robert Kenny. Robert Kenny is a technician. In fact, he won our TST giveaway to Automechanica.
Right.
Okay. And every year, what he does at the big event, he buys an extra ticket to get some technician that can't afford training.
To come.
He gets them to come out. And Robert Kenny is a true professional. Thank you, Robert Kenny. And he'll be our January 10th, 2024 speaker. And then February to be announced, maybe, who knows, Scott Brown, don't know. And then our TST big event, we're working on that. And of course, then we'll have April, May, and June. So there's what we got coming up. And enough of my yakking. We need to switch over to Scott. Scott, are you ready to take it away?
Hey, I'm here. Can you hear me okay?
I could hear you perfect.
All right. Yeah, so you want to, are you showing my screen here?
Your
Let's see if I
screen
can
is being shown, right?
See,
and
yeah,
here's
you can
your
see
mug.
me now, right?
Now, did you remember when you announced Diag.net at the TST big event?
I did, that brings back some incredible memories, right? So that was 5 years ago in March of 2018.
Wow.
And otherwise I would have been there, but I had already committed to teaching at at the ATE event up there in Seattle. And you were gracious enough to allow me to announce this new endeavor that we were pushing forward. And we launched Diagnostic Network in right at the end of May 2018. So we just crossed our 5-year, and we're cranking along. And I'll talk a little bit more about Diagnostic Network in the end. But I see in the participants there, I see a lot of names I recognize. So a lot of those folks are aware of what's going on. Yeah. And so I really, I appreciate you bringing me on here, because there's some interesting topics to talk about. And, one of the things that you guys mentioned at the beginning, old guys, right? In my shop here, I'm in my shop every day, and I've got 2 apprentices now working for me. One has been here for a little over a year. Another one's been here for about 6 months or so. And, I wish I would have done this years ago, but because I know that, I'm not going to be here forever. My seasoned technicians that are in the shop, they're not going to be here forever. We need to transfer that knowledge, and it takes a lot of time because there's a lot going on, right? It's a very complicated space that we work in, and things are not getting easier. And, you were talking about, what we went through, right? You started way before me. You're really, really old, but, back
Watch
when,
that, Scott.
well, back, I came in, I'm actually in my 40th year professionally. So I went to tech school, got out of tech school, graduated in 1983, and began starting to work in the independent market. And, carburetors were they were computer controlled on some vehicles. And back then, first thing I discovered is that a lot of the old guys that were in the space didn't want anything to do with that new computerized stuff. And I thought, that looks like an opportunity. So, I started learning everything I could, but highly convoluted, right? If you wanted to work on a GM car, you had to have these different tools and service information, and service information wasn't easy to get, not like it is today. If you wanted a Ford or work on Ford, you had to have this other Ford tool. It worked completely different than what a GM car did. If you wanted a Chrysler, that was almost impossible to get a diagnostic tool to talk to that car. But, we had to jump through a lot of hoops to make stuff work. And today, a new technician coming into the marketplace has a lot at their fingertips. And if they know how to leverage those tools, they can be successful. But the vehicles continue to get more and more complicated, and we need a way to transfer that knowledge. And I think that what we're going to talk about today, this AI stuff, I think we're just kind of in our infancy on applying this into what we do every day. And so we'll start talking about this here in just a second. But one topic came up. We were talking about this Corvette that we've got in the shop. We have a 94. It's an OBD2 phase-in vehicle, super clean car. It's got 40,000 miles on it, and we're doing some service work on it. And I'm working with one of my apprentices, and I was showing him, it's got a throttle cable, throttle plate, throttle cable, but it has this module or this motor on it called ASR. So it's like a traction control type thing. And I was explaining to him, I said, well, this is like the beginning of the throttle control systems that were being applied. And then, about 2000, we started to see throttle by wire. And one of my techs in the next bay over was listening, and so we engaged him in a conversation. He used to work for General Motors, worked in, dealer. And he said, oh yeah, when those things came out, all the older guys were freaking out and they're saying that this will never work and, it's going to go away. And I'm thinking, well, okay, if that was true, then they would still be living in caves, right? Just like you guys were talking about. So, things do evolve, things do change, right? And when change comes along, you need to look at it from multiple perspectives. You can't just condemn it and say never, never, because we've seen it. We've witnessed a lot of change over the years. So a lot of cool stuff.
That was that little black motor, the stepper motor that pushed the plate back and forth.
Yeah, well, it's got a cable. It's got a throttle cable that comes to this mechanism, and this mechanism can actually be decoupled through this little motor. And it's for it'll just reduce torque. Nowadays they can do all kinds of stuff, right? So they've gotten more advanced with controls, and we'll talk about that.
And don't forget to show your young guys how we had to work on Asian cars by counting blinking lights.
Yeah, by looking upside down under the seat, right? And then you're hitting the switch, and then you're writing down the numbers. Oh yeah, that was a gigantic pain in the you know what, right? So crazy. All right, so let's get started on this topic here. I don't have a ton of slides, and I'm hoping we get some questions coming in from the folks in the audience, because it's wide open on what's happening. So the first thing is that the AI, it's been around for a while. I mean, there's stuff going on in the vehicle, and let me just go through something here. This is I used to do a lot of off-road racing type calibration stuff, and I have some tools that I can get into a controller and pull the information out and just kind of look at what's going on. And I noticed this is off of I think somewhere around a 2017 Dodge. I think that's even on the screen there. Yeah, 17 Dodge Durango. And this particular customer, he liked to supercharge everything. So he had a supercharger put on it, and I was curious as to what they did with the calibration. So I pulled the calibration down, and I started looking around, and you can see here that there is let me get my little mouse here working here. You see up here in the corner, it says neural network, okay? And I'm going, what in the heck is a neural network? This is many years ago. And I have a colleague that I've known for several years, and he works for NVIDIA, and he's actually working in the drive space, the autonomous vehicle space, on technology that doesn't even exist today. I mean, he's working on the really way out there in the future. And if any of you were at Vision, I think it was 2019, we brought him to Vision to give a keynote and talk about what's going on with all this AI stuff. So I approached him with this, and I said, hey, what in the world is going on with this neural network stuff? And he started explaining it to me, and he said, well, basically what this is you've got a bunch of inputs that you can bring into a logic system, and then you've got a bunch of layers that basically get the output from those input, those decision making, those neural, what do they call those things? The neurons. Okay, so the neurons, just like we process things. So they then output to these other hidden layers. And this is where all the magic sauce is, right? This is where all of the fine tuning stuff is. And they may have multiple hidden layers inside of this thing. And then it comes out with an output. And so he started to explain that to me. And so I semi got my head wrapped around it. And of course I had to do a lot of studying. But the next thing that came out of his mouth was incredible. He goes, "Oh, I did not know that they were doing this with the controller." And then he started thinking, and the next thing he says, "I'll bet you this is saving them millions and millions of dollars in vehicle development, because this particular engine it's variable valve timing. It's a speed density style setup. It has no mass air meter. But in order for them to basically predict the cylinder fill, which is basically the primary function, right? We need to predict what that cylinder fill is so we know how much fuel to add for the target air fuel ratio. And then we're, of course, looking at what the outcome was. Well, they need to do this across a very wide operating range at various valve timing events, right? Because that can all affect the way that you're loading the cylinder. And he said, he started explaining that how intricate this is to actually fine tune it without a neural network. And he says, wow, they're applying a neural network. And so if we look at this chart here, we have a set of training values that they basically start with. And so they can say, oh, this is the exhaust cam maximum angle of operation, the minimum angle of operation. Here's the intake camshaft max and min. There's your P ratio. So that's like cylinder fill. So they're going over 100% there. And then they're showing the minimum. So they're showing the operating range of the cylinder fill. And then they've got RPM, max and min, and then VE max and min. And then they've got some multipliers and there's probably other stuff here that's not even being shown, but they bring all that in, and then they open up, they have these layers where they fine tune all this. And, at the factory or development, they're doing the supervised learning. They set up these parameters, they run it through all these tests, and then they see, hey, how did we do? How did this thing do on its guessing for looking at patterns? So that's essentially what's going on. It's looking at patterns, and it's recognizing that, oh, hey, with this set of parameters, boom, this is what the fill is. This is how much fuel we need. And then they, of course, they look at the output and it's decide that, hey, how did I miss, or did I miss? And then we add fuel trim and that kind of stuff. But this is pretty amazing stuff to see that this is actually going on, because like I mentioned before, I used to do a lot of race car calibration stuff, and we were running a pro race team with a Motec controller, and it was all speed density, and we had actual throttle by wire, launch control, and all that. And we would basically go through and do our cylinder. We'd predict what we demand, what air fuel ratio we wanted. And we're actually filling in a VE table point to tell it, hey, this is what the cylinder fill is percentage wise, so that it knew how much fuel to add. And once you go through all that and get all those predictions right, that engine runs really well. Well, now they can basically put an engine in development, turn on a neural network, or leverage the power of a neural network, and make things work. That's pretty amazing. But one of the things I did find interesting, over the years talking about this, and one of the guys that some of us know, Paul Baltusis, and I know Bob Grzinski's in this in the room here tonight, and he knows Paul very well. And there was a conversation. We were talking about neural networks and some weird stuff that was happening with fuel control and that kind of stuff. And he was talking about how Ford had deployed a misfire algorithm for their V10. So the V10 engine was a little more complicated as far as figuring out what misfire was, because they're looking at crankshaft acceleration per event. And he went in and he revealed to us that they went through and they did a bunch of research and development and actually developed a neural network to do misfire analysis on that V10 engine. And it worked really good in the lab, but he said when it got into the real world, it didn't work. And, they worked on it. And he said, in the end, he said, it was an interesting experiment. So when he said that, I'm thinking, oh my gosh, think about how much money was spent in that development to find out that it didn't really work well. So pretty interesting stuff. So do we have any questions about any of this stuff here? Is this an interesting topic?
Nothing yet, Scott.
Okay. So I do have a little bit more about this. So I had a car in recently that had some interesting behavior, and I strongly believe, I don't know for a fact that this controller is using that, but I strongly suspect that they are using some AI type neural networks to make their systems operate. And this particular vehicle, and I've seen two other vehicles with the same fault, and it's a P2638. It's a torque estimation issue. And what I found in my research is that they're primarily looking at airflow to estimate the torque that's being delivered to the engine. And on this particular one, this is the freeze frame data from the vehicle. And I just wanted to point out here that we've got, the driver request engine torque, we've got 19.2 Newton meters. And the calculated engine torque was minus 17.8 Newton meters. And so, I looked through the service information. There was a bulletin about a calibration, but this car already had the latest calibration in it. And what I ended up doing on this is I inspected the throttle plate and did find that it had some coking. And usually what I try to do before I do any repairs on something like this is to try to get a baseline of where the actual throttle is. In some cases I can get, you'll see a correction value, from the PCM's giving you some sort of correction value that it's having to add to the base throttle. But on this one here, all I really saw was it was the throttle position there. It was at 4.3. And so, I'm logging that, and really, if we pay attention, and let me just go full screen here because you don't really need to see me talking all the time. If we look closely, we can see, 4.3%, but over here we have the mass error is 3.7 grams per second. Manifold pressure is 25 kilopascals. And, our equivalence ratio commanded, we're in total fuel control. It's looking at for close to lambda 1 there. And the closed loop, it's in closed loop, and the fuel trim values, this is a V6 engine. So we have 4.7, the long-term and short-term are, within 5%, close numbers. You look at the fuel rail pressure, 3,500 kilopascals, the voltages, everything seems very normal. So we go through and we clean the throttle on this vehicle, and I made an observation, and boy, this thing really went sideways. So you can see now we've got 2% on the throttle, but I did not do the learning at this point. I just basically cleaned it up. I fired it up. I was warming it up, running it. And there is a specific procedure for doing, a throttle relearn on this vehicle, but I didn't do it yet. I was just looking at making some observations, and I decided to just take it down the street, drive it around the block, and bring it back just to see if it might have corrected. But look at these numbers. They went out in left field. The short term is at 46% on both banks. Long term is still kind of elevated, but if you look, our airflow numbers and the fuel pressure, everything is the same. So what I feel was happening here, and this is part of my diagnostic process. I come up with a hypothesis on thinking, well, what might be happening? What might make sense to me? I'm looking at all these values and I go, wow, something must have changed. But I think really what's going on is that the system now sees the throttle closed, and that is one of those input values that it did not have correct. It now sees this number that's out in left field, so to speak, because it hasn't been retrained or relearned. And it's arriving at a different pulse width for the injector. And now we have this crazy fuel correction. So of course I go ahead and run the automated test through and relearn everything, and then drive it around, and my fuel trims return. Now, I still had a little bit elevated long-term, but as I drove the car more after I recorded this, those numbers started to come back down. But I thought that, that this is the kind of stuff that can throw you for a loop, and you can end up spending a lot of time because you didn't follow the right instructions after repair. So it's really important, because thinking, if you're trying to think about, hey, wait, the airflow numbers are correct, the manifold pressure is correct, fuel pressure is correct, how did it change this much? Well, I believe that was because there was a repair done. There's a neural network or some type of AI running the system that just it needed to be reestablished, that bringing that throttle back to normalization, and then let the system take back over. So does anybody have any questions, any input on that?
Scott is really
Okay.
clear, so I don't think it's my computer. It's about
Can
blurry.
you see
stuff.
that?
So
Yeah,
I
there's-
guess your slide, they must be talking about that. I mean, I can see it okay.
It's our TST slide, by the way.
Okay. Yeah, sometimes, I know that Zoom will, I'm pushing out a 1080p ultra high res. This is a real clean feed. It looks really good on my side here, but sometimes Zoom does some things. It's kind of like throttling, I guess, where they are looking at your bandwidth, and then they're trying to trim that down so that we're not losing stuff. It's unfortunate, but this is the world that we live in.
It looks good on my end, but I think it depends on the person's computer connection.
You're switching us.
Yeah.
Yeah, when I speak, that's what happens.
Yeah, so I see Bob Grzinski. So I don't know if you guys know who Bob Grzinski is, but he's one of those the grandfathers of OBD2, super sharp guy. I've had the pleasure of talking with him many times over the years, and he says learning algorithms come in many forms. So it certainly could be a neural network. Yeah, so pretty cool.
That's one smart guy, that Bob.
Yep.
Bobby
Yeah,
G.
Yeah. Yeah. So, Robert McElroy says, for the vehicle at this point, what procedure would you suggest, or what reference? So, I mean, this is why you have to specifically run what the manufacturer states, right? They say after cleaning the throttle body, run through this process. Make sure you do this. And I think it was fairly easy to do. We used HDS to do that one on that vehicle, and and after we were done, it worked out really well. But how many people jump in there and just clean the throttle plate, and then send it down the road, and then the customer comes back. This one would have come back. It had a pending fuel trim code in it, so it definitely would have, if I wouldn't have noticed this, and if I didn't do the learning and send it down the road, I would have looked like an idiot, right? Customer comes back complaining. So yeah. But yeah, it's pretty interesting stuff. So I do have a couple other things here that we're going to talk about. So we'll shift gears here. So there are some more questions coming in here. So what's the difference between a learning algorithm, such as a conventional oxygen sensor, and a neural network, for example, for mixture adaptation? Yeah, that's a good question. it depends on what these OEMs are doing. So think about what the OEM is taxed with, right? They are they're getting pushed more and more to come up with better fuel economy, more efficiency, lower emissions, and they've got to figure out how to peel that onion or skin that onion down to the point where they're refining this stuff. And so they're adding all these extra controls and making these systems work work better. But they changed the rules. I mean, there's things that happen that are different than what we were originally. If you look at an old speed density system and understand, you've got a XY axis, right? You've got a manifold pressure point, you've got an engine RPM point, and that specific thing, you're predicting that the cylinder fill at say 98 kilopascals is close to 80% fill. But down here at 40 kilopascals and 1500 RPM, you can fill the cylinder at about 36%. And so, they map all that out, and that's for a fixed cam timing vehicle. But now we've got multiple cams, multiple angle, variable cams, and now some of those vehicles have variable lift, right? So think about what a BMW might be doing. I'm sure there's some really wild stuff going on behind the scenes to make these cars run and perform properly for hundreds of thousands of miles. It's pretty amazing. All right, so let's see. Bob is yeah. So there's some good stuff. It's a methodology of putting together the algo. Guts and diagram and description is one way. A sort of between max min is another. Yeah, so I would say the takeaway here is that if you haven't really looked into this kind of stuff in the past, it might be worth taking a little journey to expand your knowledge on what's going on behind the scenes, because it's absolutely incredible what they're doing. Right, they're doing this with the engine controller, but you're going to see just a little bit what's going on with computer vision. And what they're trying to do, they're trying to get a machine to make sense of the world and interpret things like we as humans do, right? So the way a human is processing things, that we learn over the years on how to identify certain things. We can identify a fire hydrant, a dog, or what have you. But now they're trying to get these machines to identify what these things are and how they behave and what they're about to do. And so let's go into the self-drive or talk about the cars for a little bit. The perception systems and how it's going. I do have a full disclosure. I do have a car that I drive every day. I bought it new. I have about 75,000 miles on it. So I got a lot of seat time, and it's a Tesla Model 3. And it has what's called the hardware 3.0 on it, if you know anything about their system. But that's their new processor, and it's got 8 cameras, and it has a radar sensor that's now no longer being used. So it's basically deprecated from being active in the perception. So they are using primarily just cameras to understand the world. And this thing has what's called this full self-driving beta application, and it's pretty cool. I have a screen here that I'll show you, and it doesn't work perfectly all the time. So this is so I've got some apparatus on my vehicle that I can actually record like all the raw data from the screen in the car, but it is showing that the car path. I'm making a left-hand turn. Two cars making a left-hand turn. That pathway you see there in blue, I named this the Crazy Ivan because basically what it was doing, it thought that it was going to go in the opposing traffic lane to execute this turn. It was just totally wrong. So I had to like turn the wheel and shut the system down. But it's pretty crazy that this was a couple years ago. This may actually have been 3 years ago. It has not done this particular failure since, but it's pretty amazing that there's some crazy stuff like this that's going on, and it's trying to process the pathway and actually navigate the car. In this vehicle, it has it has full control of longitudinal, lateral control. It will drive, it'll basically change lanes, it'll make turns, it'll merge onto the freeway, it'll merge, off the freeway, change, it's pretty incredible. Come to a stop sign, it'll come to stop at lights. When the light turns green, it goes ahead and proceeds. It's pretty amazing to see it work. Like I said, it's not 100%, but it's pretty amazing on seeing a vehicle actually being able to perform tasks like this. So, so this next slide here, I use this and I do a lot of ADAS training, and I do a lot of research on what these perception systems do. And I actually have some little perception system devices. I have an NVIDIA box, and I can run some open source software. This particular video I'm going to play here in just a second, and I hope it plays well for you guys. And what I did is I actually recorded some video with a GoPro, and then we brought that video back. And one of my techs here, he's got a gaming computer, a pretty high powered machine, and we started using this other open source software called YOLO, YOLO, and it's basically an acronym for You Only Look Once. Okay, and this is YOLO 8, so it's on an eighth generation of development, and it's open source. So there may be different groups actually developing the software for the next generation. A side note on the YOLO stuff, the very beginning, the guys that invented the YOLO algorithms, or whatever you want to call it, one of the engineers, basically, he checked out. He saw what was going on with the AI, and it spooked him. And he's basically unplugged from all this. He's no longer doing anything related to machine learning and that kind of stuff. But which, that's whatever floats your boat, I guess, right? Or whatever influences you. But we took this high-res video and basically ran it through this YOLO V8, and then this is the output of it. And watch what happens. This vehicle, or this system, it starts to identify and classify objects, and it's also predicting, where at in the Z space, or the volumetric space, on where these things are at. So let's just play this through, and we'll just go full screen here. There we go. So the numbers you see on the top there, those are the confidence numbers. So, 80, 90%. But if you watch along the right-hand side, you'll start to pick up, it'll see people, and sometimes they're not easy to see. The system is able to predict with a high level of confidence, where these folks are at, or these objects, and where they are in relationship to the vehicle. And this comes back to, this is another reason why calibration is important, because that location of that object is referenced back to a datum point on the vehicle, so that it knows, the car then knows how to apply any type of corrective action, whether lateral or longitudinal, so that it can avoid hitting something, right? An obstacle, or causing harm to someone. But you can see the things it's trained on: cars, trucks, and then you're going to see here in a second, when it comes up to the street lights, how quickly it sees the lights. The street lights coming up here in just a few seconds. See people walking on the side there. It actually saw the sign there for the lights, and it classified that. But you see the traffic lights, they're all being identified there and picked up. And you saw quickly that car coming across. It's pretty amazing technology that that is happening today. I mean, it's pretty incredible. So one of the one of the crazy things here is that this is actually off of my vehicle. I've got sound going. I'm going to just narrate. So this is my screen and an actual camera view out of the front of the car, and you can see I'm coming to an intersection, and it looks like I was the first one there. The car is doing everything, and it went ahead and made its decision to go ahead and go. The next intersection here, you're going to see a pretty complicated scene, and the car handled everything properly. You will see two pedestrians that are walking across my pathway, and then you're going to see another pedestrian that starts coming on the right side, and it's basically prevents that other car from going. Although he was there first, and now it says, okay, I'm going to go ahead and go. Pretty amazing. I mean, that blew me away. And I have a lot of examples of this system performing some pretty interesting things. So things that happen just like a human would handle the situation. So I share those in my class, and I think that maybe somebody was I was at ASE conference, educator conference last month, and I had this video that I show where, and you'll see I'm just spinning the car around, or spinning the view around on the screen there. It's just amazing on how it can reconstruct the environment around the vehicle. But anyways, what I was explaining is that I had this event where I'm driving down this road, and there's a jogger he's running in the street between the parked cars and the traffic lane. And I'm driving along. I was recording all this, and I was waiting for the car to see what was going on. I thought I was going to have to take over, but the car saw the pedestrian, and you could actually see the path planning way ahead of time. It had already mapped out its path planning, and this is all neural network driven. I mean, it's absolutely amazing on what's actually taking place there. So yeah, so let's stop for just a second. Do we have any particular questions that I haven't seen yet? Gee, and can you
Not that I noticed.
No? Okay. Okay, so oh, I do see, yeah, somebody said they were Tracy Hicks, and I recognize that name there. He said he was at ASE, and they got to see cool stuff they don't normally get to see. So so the name of YOLO creator who left is Joseph Redmond. Yeah, I pretty amazing that that decision. I mean, it's crazy. I mean, you look at this stuff could get there's some bad stuff. I'm sure there's some bad actors that can take this stuff and do some bad things. So it's you know, it's going to be an interesting decade ahead to see what starts to happen as far as you know, transforming the world that we're all living in here, right? So pretty cool. So one of the other things that I found recently, just in the technology, this stuff is moving so quickly. It's absolutely amazing. So we all know that during the COVID thing, the COVID event, we had this thing called chip shortages, right? So a lot of orders got pulled. You know, people stopped production of cars, so they didn't have to have all these things built, and caused a big disruption in the marketplace. And I mentioned earlier that the Tesla Model 3 that I have in I think it was 2021, they stopped putting the radar sensor on the cars, although the harnesses are still there. And I believe they did that because there was a chip shortage, but they also had a technical presentation that you can go look up on YouTube. They have engineers that actually give a presentation on how their neural networks are working and the performance of the vehicle. And they were claiming that the radar data was getting in the way, meaning that it was causing a lot of false positive data, and that their camera vision system had advanced so well that it superseded they found out that they didn't need the radar anymore. So that's what they made a decision not to use the radar anymore, and there we go. Well, now today, or at the beginning of this year, the hardware 4 stuff started showing up on Teslas, and primarily the Model S and the Model X, which are their top level vehicles. We saw that radar came back online, but it is a new radar. It's called a high definition radar. And if you want to, you can do some Googling, or if you want to send me a message or what have you, I can send you a link. You can actually go to the FCC website with the FCC ID that I have, and you can get a picture of what this radar sensor looks like. And on the inside, you look at all the transmitting and receiving antennas. It looks unlike anything that I've seen on any other vehicles in the marketplace today. But to this particular thing here that we're looking at on this, here, let's go full screen. This is on a 2022 Honda Civic, and I purchased this camera primarily. I got it on eBay through LKQ, wrecked vehicle. And what I noticed right away was that there's this nice sign on the back of it that says misaligned camera unit can cause improper system operation, resulting in a crash and injury or death. That's a pretty bold statement, and I think it's a pretty severe statement, meaning that, hey, when we're doing service work, we need to make sure that we're performing the proper services to put the vehicle back into operation. And you can see the last statement there: always have an authorized dealer calibrate camera after camera or windshield replacement. So, that's one aspect. But this particular car, this 2022 Honda Civic, and I believe it was 2021 model year that they started with this, they also deleted the radar sensor off the front of the car. And they went to this new camera that still provided the same or better performance in delivering the adaptive cruise control, automated emergency braking, lane keeping assist, all of those functions all through this one particular camera. And so I was curious to find out whose camera, whose technology, because it's hard to really learn all this stuff. It's not easy to uncover all that, but I found out that, I started taking my camera off my 2012 or 2013 Volt when I got it, that had a forward facing camera. And I wanted to get the chipset, numbers and do some research to figure out who makes it. This one here, I took apart and looked at the inside of it, and you can see it's a Mobileye, and it's an IQ4M. Okay. And that, so I went to Mobileye, which is actually an Intel company, and I did a little research on that particular system. And this is a 2022 model year car. And I go to Mobileye and I look at what they're selling now to the marketplace. And you can see that they now have a Q6. So there's 2 generations that they're now advanced in, and current production is delivering, when it's two back. So a tremendous amount of stuff going on here. So it's absolutely amazing. In 5 years from now, we're going to see cars that are doing some pretty incredible things. I feel based off of what I'm seeing here in this space, and primarily a lot of this computer vision stuff is driven by running these neural networks, or this AI, computer vision, machine learning algorithms, and so on. and it's pretty exciting. So any question on here? Okay, I do see Craig says open source means not copyrighted. So, you know, that it does bring up an interesting thing. How many here bought computers in the early days, right? Had a computer maybe late 80s, early 90s. How many remember getting a scanner, a page scanner that had what's called optical character recognition? So
Yep, I have
yep, you remember that? So it would basically, you would scan a page and it would take the characters and move them into an editable document, right? So take them into Word or something like that. So that, I strongly believe that was the beginning of this computer vision age. And most of that was born up north here. It's still in the land of fruits and nuts. I don't eat granola in the morning, so gee, I think you know that already, right? But up there in the Silicon Valley, there's a lot of a lot of stuff that's happened in the garage, right? These guys are coming up with crazy stuff that they're doing, and somebody said, hey, why don't we see if we could figure out what get the machine to figure out what's going on with these items, right? And so, you know, you start off with OCR, it's figuring out that's a C or an I or a T or whatever. And now here we've got computers and cameras able to assess the volumetric space out in front of the vehicle and around the vehicle. It's pretty amazing. There's also a ton, computer vision isn't limited to automobiles, right? It's endless. My mother was in imaging in the medical field for years, forever, basically. They were doing x-rays and then MRIs came in place. Well, they have probably for the last decade have been taking these MRIs that have been analyzed by doctors and identified, and they feed them into these systems to help them train and identify things. And there are things getting picked up by machines that a junior doctor or somebody that doesn't have a lot of experience may not be able to see, and the machine vision is helping them actually see the anomaly or see the thing. So looking at that and applying it to our marketplace or our world, I think is that this is inevitable. I mean, these are the things that are going to come into our space to help us divide and conquer or solve problems on automobiles. Any feedback on that, or any other feedback here? So I do see a lot of discussion here. So, and back to the open source. A lot of the stuff that you see on today on an automobile, you could go look at a Toyota or in another manufacturer, maybe a Honda or a Nissan or whatever. They may actually have a camera system that was made by the same vendor, right? So say the vendor was XYZ, and they will start with an open source, object detection, classification. They've got semantic segmentation, layers. They've got pose detection. So they're looking at the way that a human is constructed and, where they may be walking. And a bunch of these other open source things. And then their development teams will take and refine that and make it better. And that's why you see some cars perform better at doing like lane keeping operations than another car that you think might be equivalent, but that manufacturer did not put the same development into refining how that system is processing the environment. And I rent a lot of cars. We do training on ADAS stuff. So I do try to rent different types of cars. And I notice this. I notice a lot of cars have varying performance where I feel like they should all have equal performance, but it's it's just how much development that they want to put into that vehicle. And again, thinking about what the return on investment is. So let me scan through some more of these questions here and see if there's Anything else here? Yeah, people love new features until they have to be repaired. Yeah, and so that is another thing I think that's really something we need to pay attention to. All these features on the vehicle, I see it over and over again where a customer or a client buys a new car, they don't get properly onboarded into that car to understand exactly what, you know, how the system works, what to expect, what normal behavior is, when it may not work, and maybe just normal. It's outside of its, they call that operational design domain, right? The system has not been designed to work outside of these rails here. And I think that us, you know, I'm looking at I'm a independent service provider. You know, we are fortunate we have multiple generations of customers that come to us. And I strongly feel that we need to be the trusted partner, the knowledgeable partner, so that when a customer comes in and says, hey, what's all this? What are these letters on my dash? I've never seen these before. What's this all about? You know, you don't want to go out there and say, well, let's figure it out. Or you want to be able to address them and you know, bestow some confidence into, hey, oh, that's part of the lane keeping assist system, LKAS. And we've actually had these situations come up in our shop. We've had customers that come in and they accidentally hit a button on the dash and they didn't know what was going on. So I think that even though we have all these systems and of course that can introduce headaches, but we're in the repair market and we want to become trusted experts on this stuff. We need to learn it and have it part of our vernacular so that we understand how to deal with it. All right, so and G, if you've got something you want to chime in, feel free to drop it in. I don't want to sit here and filter through all this stuff if you've got something good for me. Does climate condition affect ADAS operation of autonomous vehicles like driving in heavy rain? Can it identify objects? All right, so that's a great question. Yes, of course. So if you look at the SAE's J3016, they have the 6 levels of automated driving. So we have level 0, which is primarily just warning systems, really no controls over the car. And then you've got level 1, you've got some control, either a longitudinal or lateral control. Level 2, which is primarily what we see today on the later model cars, where it can do both controls. When you get up to the level 4 and 5, that is predicting when there's probably not going to be a control in the vehicle, and it says it can drive anywhere at any time and within its operational design domain. So, you know, a roadway with clear defined lines and you know, it can see, it should be able to drive. But I can tell you, in my car, I'll be driving, and if it's raining, I will get a message that will say, you know, weather detected, full self-driving, not available, right? So it may still give you some level of service, but it's giving you a warning. And by the way, when you have steering controls in your car, you are ultimately responsible for safe operation of that vehicle. So, you know, there's a lot of controversy out there. People are going, oh, I had it in auto drive, like G was talking about in the very beginning, where somebody ran into the back of a safety vehicle or a, you know, first responder vehicle. Well, that was the operator has got to be, they've got to have their you know, heightened status of awareness of what's going on. And when the system isn't working properly, it needs to be able to shut it down. I just had a gentleman in here the other day. He actually used to work for me, and he's an inventor. He's done all kinds of crazy stuff. Well, he was telling me he had a Model S that it sideswiped these barriers, these K-rails in a construction zone. And he was going through the sweeping turn, and the car, you know, it kissed it and hit it. And he goes, yeah, I think something's wrong. Tesla's got it. They've got to make it right for him. I go, dude, you are ultimately responsible for the operation of that vehicle. You are not, they're not going to fix that for him. But And if you guys are interested in it, there in more of that kind of stuff, there is a I believe it was NHTSA or the Department of Transportation. I believe it's NHTSA. They had this, they called it a standing order that went out, I believe in 2021. And anyone that is delivering a level 2 vehicle into the market must report incidences of collisions or events related to their driving assistance systems. And if you go to that, whatever that website is, you can get all this full reporting. It's all, it's all public information. And what you will see is a ton of Teslas in there. And if you start reading through the minutia of what's going on, and why you see high population of Teslas, well, primarily that's because the Tesla vehicle can report that data right away. Other manufacturers, and what I've found is that it takes time. The manufacturer actually has to go to the vehicle to get the data and to pull the data out. But it's pretty hilarious to read some of these things there. We had this, there was one I remember reading there that the guy mistakenly saw a green light on his display, and he thought it was the green light for the traffic, and he hit the throttle and he ran into, or he got got T-boned. And they actually mark in what the operation of that vehicle is. And the guy claims that he was at a light and he's leaving, and he said he had adaptive cruise control and steering active, which doesn't make any sense to me. But there was another one with a GM car running, what is their system called? Boy, I'm drawing a blank here. But anyways, GM has their cruise, right? Their super cruise. And yeah, and they basically, I saw the report, and General Motors had this report, and it says, 15 seconds before the collision, the driver unbuckled his seatbelt. Okay. And then it was like 5 seconds later, the steering wheel made a 30-degree turn to the right, and the guy was going pretty fast, and it basically, he hit an embankment and then went off into the and crashed the car. Well, then they got a statement back from the driver, and the driver said, oh yeah, I was trying to get something out of the back seat while he was driving. And so, I mean, the human element is going to play a big role here. So it's pretty eye-opening to see that kind of stuff, because now it brings awareness to the complicated space that we live in. And we've got drivers out there that don't know what they're doing and causing problems.
Well, Scott, you can't fix stupid, right? And people like someone wrote here, they don't read the material about the car, what the car can do or not do. And as you stated, the driver is responsible. It's not a self-driving car right now.
Yep. And if you're doing research, you're trying to get educated on what all these ADAS systems do, that owner's manual has a lot of really good data. I mean, sometimes I get more data out of the owner's manual than in the service information on description and operation. It's pretty amazing. And if you think about it, that is the last level of legal, right? That all went through all the legal, the OEM's legal level, and it got published into the world. And so it's laying down the gauntlet on how these systems work. And you will find, if a customer is complaining about something not working properly, and if you go into that book, you will probably find that that's normal. That system isn't designed to see certain things. And so that will help you from trying to fix something that can't be fixed. Right. So none of us want to work for free, or learning about stuff that isn't working, because that's just the way it is, right?
That's a good point, Scott. That owner's manual does have a lot of good things in it. Even something as simple as oil level. Sometimes people get a new car in and they put too much oil in the vehicle.
Too much, or they're not even thinking about it anymore. Yeah, we had a local. I remember this guy. He was a local priest, and he would get a new car every couple of years. And he brought the car in one day, drove up the driveway, and he goes, "Hey, this light's on. I don't know what it is. it looks like the little genie in the bottle, right? And I'm going, well, and I can hear it clicking, and I go and I check it and I go, oh, there's no oil on the dipstick. He says, no oil. He says, it's a brand new car. And I look at the odometer and it says 12,000 miles on it. Well, he got a new car, he drove it, and he never did any service work to it. And the thing ran out of oil. It's just amazing. So it's a challenge to deal with the public sometimes, right? So, yeah, somebody's saying, so Chris, I'm just scanning through this right here. Chris says, you have to sign an NDA to interview for a tech position at Tesla. I can't say more. Okay, cool. Yeah, I can tell you that if you have an opportunity, or if you have somebody young and they're looking for something to do, Tesla, have them go to Tesla. They will give you training. If you get a couple years in at Tesla and learn their architecture, you're going to have a place in the market. I guarantee it. I mean, maybe in some geographic regions where you don't see any Teslas, you might have a challenge. But here in California, you know, we're starting to see Teslas that are out of warranty, or some that are still in warranty, but they can't get into the service center because their bandwidth is full. And so if you're able to bring some knowledge and information to to a service center, and now you're next Tesla employee, and you can you want to further your career, and you want to bring some skills into a new market opportunity into a repair center, more power to you. So I assume, Chris, you're working for Tesla, right? All right, so let's see. Yeah, even with self-driving and driver skills, yeah, when I drive it actually, I feel like you're supposed to be driving and have less driver workload, but I feel like I'm paying more attention than I would just normal driving, right? Because sometimes the car is actually trying to make a lane change, and right now they have the full self-drive that happens everywhere. Before it was just streets, and then on the highway you would have this cruise mode, and it would request a lane change and you would have to acknowledge. Now it just does a lane change for you right away. And sometimes I see its decision to make the lane change didn't really meet my expectations. So I can't imagine what some people that aren't really in tune with what's going on, and they're experiencing this stuff. So so let's see. David Pearson, I follow some reprogramming guys and podcasts that do ADAS, and they record before and after the cover working. They buy Audi and BMW, Mercedes first to get in the door. One pedal driving on one car is different than another. I noticed on the Mach-E, it's not as good as the Chevy Bolt. Yep. Yeah, drive these cars. That you got to get seat time on all these different cars to understand what's normal and what's not. I drove a new Telluride the other day, and it's got this smart system on it, and I didn't read the manual, but I just took it out to see how it worked, and I noticed that they had turned off the lane keep assist, and when I turned it on, I'm driving it down the road, and it felt like a pachinko machine. It was doing this. It was like it was always hunting for the center of the lane. I go, this doesn't seem right, but that's where we're at. Let's see. What's the use if you have to monitor the driving? Yeah, so it's called beta, right? So they are learning, but I can tell you that I've driven to I've driven Northern California many times. I've driven long distances, and it is, when you get out on the highway and you've got lane keeping and you've got adaptive cruise control, it is definitely and you don't have a ton of traffic to deal with. It's nice. You are not taxed. You're actually able to look around and kind of see what's going on around you. The latest thing I noticed that on Tesla, what I did notice earlier was that it always kept you right in the center of the lane. Even when you're coming up alongside of a semi, it would always stay right in the center of the lane. And it's like, when I'm driving, normally I give myself a little buffer. that car now does that buffering automatically. It will basically, it'll start to ease over to the left side, give you, or away from the semi, give it space, and then once it gets back, you see it come right back into center, and it does it just like a regular human would do it. So pretty cool. All right, so yeah, the Mach-E knows when you don't have your hand on the wheel. So yeah, a lot of that stuff is a torque. There's a torque sensor, for EPS. Tesla actually has two. Their EPS system has a redundancy system. It has two power supplies, two of everything there, and it basically is monitoring your activity on the wheel, or any of the controls. So you have your volume or your speed control, any of those buttons. If you're touching those buttons periodically, then that's qualifying as being attentive to the wheel. But it's also using an interior camera to monitor your activity. And I've been caught with this before. I'm driving along and I was trying to film something on the screen that was happening, and I'm holding the camera, I'm watching the road, and it kept giving me, it said, put your hands on the wheel, put your hands on the wheel. And it kept giving me these alerts, and I put the phone down and put my hands on the wheel, and the error went away. So they're watching what's going on with your behavior on the vehicle. Okay. Yeah, so Gary says we have a long way to go with this, even though technology is moving quickly. It reminds me of the mechanical fuel injection back in the 50s. And the next round happening in the 80s on electronics made a big impact, going from electronic throttle body injection to what we have today. Yeah, direct injection took a long time, and direct injection wasn't such a great idea after all, right? I don't know if Bob Grzinski would have an agreement on that, but we've had, what do we see in the field on a long, a car over time? We see lots of carbon buildup and other things happening because of the GDI systems. We're moving more oil through the intake system, and it's not being cleaned off the intake valve. All right. So anyways, we're going to move along here. We're going to talk a little bit more about this. So actually, this is the interior. I took some pictures of the camera. And so let's look at this closer. You see the size of this imager. This is off that 2022 Honda Civic. You look at how big and wide that camera image is. And you can see if you look at one of these, you'll notice right away that usually you have you'll see the little V in the window. These here, you will see a super wide opening, big berth opening. And I've seen them now on Cadillacs, Hondas, and I believe some other, I think I saw one the other day on a Lexus. So they're going to this camera that now has a much wider view, but I know there's a lot more magic AI being leveraged on the backside. But if we look at this is the Tesla camera right here. It has 3 focal length cameras for the forward facing camera. And you look at the size of those imagers there. The latest hardware 4, they've gone to 2 of these cameras now. So it looks like there's 3. If you're looking at the car, you'll see 3 that looks like 3 lenses, but there's only two there. And so you know that they're advancing their machine vision technology and doing more with less. So that's pretty cool. All right, so let's move on to the AI around us. So I'm sure that everybody here by now has heard of Chat GPT. I am not an expert in this, but when it started coming, when it was available generally to the public, to a beta, I believe it was November of last year, I signed up right away, and then I got into that and started playing with it, and it's amazing. I use it a lot. I now have all of my staff members up in the front office. They all have their own Chat GPT account, and I get them to leverage it to write. They want to write communication pieces to a customer. They use it. So, and we'll talk a little bit about that here in just a second, but this is a real world thing here. I had one of my relatives had a question about something going on with them, and they wanted to know what could be going on. You know, they didn't want to necessarily go to the doctor right away, but they wanted to know what could be going on here. And so let's go full screen. I'll just walk through this. So I'm working with this person who is somewhat, knowledgeable of medical, and it says, what might be wrong when there's a sharp multi-point pain sensation emanating downward from your right mastoid? So right mastoid is in your, I believe it's in back of your ear area, I believe. And this is the answer it spit out. It's difficult to determine the cause of your pain without more information or medical examination, but it's possible the pain you're experiencing could be caused by a number of different factors, including muscle tension or strain, nerve irritation, compression, problem with the bone tissues in this area. Some potential causes of pain in the mastoid area could include an ear infection. I'm not even going to try to pronounce that word, or TMJ, or even a headache or migraine. Okay, so I mean, this is, it's pretty amazing, but you have to understand the source, or how is this working? And again, I'm not the technologist, but what I do understand, they're using these large language models, so they have access to a ton of text, and these systems are learning what text goes with other text, right? So maybe they're looking through medical journals or what have you, and they're able to discern certain words go with certain things, and they're making logical sense out of what's happening. And that's a super simplified view, and it may not be totally accurate, but there is so much movement in this space right now. It's absolutely incredible. So we at Diagnostic Network, of course, I work with a couple of folks that are super smart, and we've been talking about machine learning stuff for a long time, and it's here, it's here, it's happening. So it's going to affect us one way or another. And so one of the things that I'll talk about Diagnostic Network here in a second, but just a couple more things I wanted to emphasize here. The automotive service, if you're not using this in your operations to help you either navigate your business or work with communications with your clients or what have you, you're doing yourself a disservice. That's my personal opinion on that. But I'll give you a couple of examples. You can go and create a calendar. There's some third-party companies out there, but you can create a calendar of advertisements that you can push out for your business that are tied right to your business through social media by going through and doing a couple of steps. They'll create some artwork for you. They'll create these little blurbs about your business, and you can then just put it in the calendar and then have somebody post it to social media to bring awareness about what your business is doing or what have you. Anything you do in your company as you're communicating with your clients, you are marketing. You're marketing yourself. So, using good, concise language, proper language, concise language, explaining things in a way that the consumer can really benefit from is great. We used it not too long ago. We had a customer that came in that he had the car to the dealer for some stuff, and they weren't able to fix it quite right. And then we ended up making some repairs, and we found some faults on that vehicle that were fairly commonplace. And we ended up doing a lot of work. And I went ahead, I had this Chat GPT write a letter or draft up a letter to customer service, quality assurance or whatever for that manufacturer. And we gave that to the client. The client looked at that and he says, oh my gosh. He says, if I send this in, put my name on it and everything, do you think they might reimburse me for some of this? I said, hey, it's worth a shot. But if you read through the document, it's golden. I mean, it constructed the document in a way that told a good story, and I think made a great presentation for the client. So, but just think about that experience with the client. You're able to bring forward some communication and help that consumer perhaps get some type of reimbursement. But the sky's the limit here. You can really leverage the heck out of this stuff and even do some research. I mean, you can do research on vehicle problems or what have you. So what we did with the diagnostic network is that we've been working on this for many months now, and we got it to we were running basically a parallel system in our test environment and having it answer all the different types of questions that come in. There are some things that come into diagnostic network that really don't warrant this guy, who is called Aiden, by the way, AIDN. And we had it walking through a lot of stuff, and we're looking at these answers and stuff, and we're making some tweaks to it. And we finally, it was in the end of June, I believe, or beginning of July, we rolled it out as a beta. So version 1.0 beta. Again, it's not going to be perfect, and it's not perfect, but it does a decent job. But if you look at what's going on here, we're just at the very beginning of this, and it's also dependent on what the system is trained on. I can tell you that it's not been trained on much. Not a lot of technical content, but just imagine what can happen if the system is trained on some highly technical content that's very specific, and it's able to basically discern what's going on. And the way I look at it is that, I look at these young apprentices that are in my shop, and when they start getting into diagnostics, and maybe some complicated diagnostics, that car comes in and it has, a plethora of DTCs, where does that technician start? How do they develop their strategy? This is something that could give them a starting point, right? It could give them some logical steps. And if you've been on diagnostic network, you've witnessed some of the stuff, you see some things that may be very, very basic. And of course that's normal. We have a lot of really super smart people on diagnostic network, and so it may look very elementary, but think about somebody that's new starting out in the field, or somebody that's just gotten out of tech school, and they're learning all these new things that are happening with vehicles, or learning some new best practices. Something like this could get their headed in the right direction on making sense of what's going on with the vehicle. So if we look at this one, this is one that, and by the way, we do have a voting system in place. So if you're on diagnostic network and you see something that this thing is no good or whatever, you can downvote that thing and give it a tag and say, hey, this thing is way off base or whatever. We're going to use that on our learning end to make sure that this thing is doing the right thing. But at the moment that I saw this particular one that I grabbed a screenshot of, a few people had voted the thing up, and they said agreed, helpful, interesting, or whatever. I don't, regardless of what the question was, but it says it's unfortunate the Altel scanner is not able to connect to the AC module, blah, blah, blah. And then you see, since the passenger side is blowing cooler than the driver's side, it could be an issue with the blend door actuator, blend door itself, some general stuff. But it's amazing that a machine was able to push that content out. And so anyways, this is, again, this is the very, very beginning. So I'm interested to hear what anybody that's had any experience with this stuff, or what you guys are, what you guys or gals are running into. So let's see here. I'm going to go up. Oh, I see. Hey, this guy, there's a colleague of mine, longtime colleague, Tom Finneran. Hey, Tom, how you doing, man? It says, Scott, we are a long way from Delco Tech classes in Burbank. Yeah, we went to a lot of classes in LA, just north of LA out there, a lot of GM training together. And yeah, Tom is up in Las Vegas now. He's an educator too. Good. Thank you for all you do for the industry. So I've not been on the chat in about 2.5 months. Is still only good for 2021 information. Gary, I think that there's a Chat GPT-4 now, and that one actually is trained on, well, it's publicly public info on the internet. So there's stuff that's it's evolving. I'm only using the 3.5 for my personal stuff, and that's on the free side. But it it works. Chad says, my sales guys asked Chat GPT to explain car problems to a 10-year-old and then send a response to the customer sometime. That is interesting. When I was at the ASE instructor conference last month, I was having a conversation with a colleague who's in the publishing space, textbooks. And he asked Chat GPT to explain Ohm's law. Okay. So it basically spit out this long thing about Ohm's law. And then he basically said, that's okay, but please rewrite it at a 4th grade reading level. Okay. And it basically turned around and it spit out this whole long thing. And then he sent it to a colleague of his to have him, he didn't tell it where it came from. He just said, hey, can you review this document and tell me if it's on par or if it's, and the guy, a couple of days later, the guy responded to him and said, oh my God, he said, this is so well written and logical and it explains everything. And then they went into a conversation saying, yeah, this is how it was. This is how this was born or derived. It's absolutely amazing. So let's go down here. What I found with chat is most people that I've had conversations with do not speak on the level anywhere near what is done with AI. Gary, playing devil's advocate with AI as a consumer, they can start poking around and they may poke more than they're going to get for answers. Yeah, well, this has been happening forever. We've had customers come in and say, hey, I was reading in these forums about my car and I'm pretty sure it just needs the switch replaced. And I go, well, okay. I mean, do you want us to go ahead and take that stuff apart and replace that switch? Or would you like us to basically really analyze the situation? And they go, no, I just want you to replace this switch. And we've done that pathway. We've done and replaced that switch. And guess what? The problem didn't go away. And now the customer is a little upset, but we tried to manage their expectations and said, hey, there is no guarantee that this is going to solve your particular problem that you're complaining about. So this stuff is it's been around for a while. Let's see. How are the techs and schools adding these tech advances to their curriculums? Yeah, I'm not sure about that. Robert said, I'm a former GM staff instructor, enjoyed visiting the technical training center in Burbank. Okay, all right, that's cool. So there's a Andrew saying way off base or way off base. I don't know, what are you referring to? All right. Well, anyways, I'm probably towards the end of my discussion if we get some more questions here, but just I wanted to encourage people to if they haven't heard of Diagnostic Network, go check out Diagnostic Network. It's diag.net, and check out what we got going there. We're 5 years in. We're still a very small, scrappy little development team here, but we've got some interesting things in the back channel that'll be coming forward pretty soon to make some enhancements on search and user experience. And again, we want to continue to grow and bring forward some useful resources to help us navigate this challenging workspace that we're all part of. So I appreciate you guys being here tonight, and again, I'll be here to answer any questions that may pop up. But thank you, G and Pierre and the folks at TST for having me come on tonight and chat with you guys. I really enjoyed this. I really enjoyed talking about this kind of stuff. There's the automobile is it continues to just keep giving and giving. So it's just pretty incredible.
Well, Scott, thank you again. We really appreciate you coming on with all your knowledge and your experiments, like trying to get us picked up when I was out your way with your car that didn't work too swift.
Oh yeah. Yep.
But it's come a long way since then. And AI is here to stay, and it's just going to be something, as you stated, that we could use in our business, and you should be using it.
You know, I'd like to add a little something to this. You know, I say this to people, I say kids, but it pretty much means everybody younger than me, which is, well, pretty much everybody. And that is the three most powerful words in our vocabulary, which are, I don't know. And Scott obviously epitomizes this attitude. He looks for answers and tries to figure it out. I think, yes, I think Bernie does too.
I don't know. Yeah, I say I don't know all the time, but I'm going to find out.
The bottom line is that's how you learn, though. And I think we as an industry should not be afraid to say, I don't know.
Yeah.
Yeah. Oh yeah. It's I mean, it's pretty incredible. And I give a lot of, I remember in my early years, you would look at a car and you go, well, why did they put that together like that? Or what the hell are these guys thinking about? Right. But I have a lot more respect for what it takes to put a vehicle together into the marketplace and make it work. It's quite amazing. And we see cars lasting, hundreds of thousands of miles and continue to give good service, but
with abusive owners.
With abusive owners, but we're going to see, we're looking at a lot of all the electrification stuff coming, or it's here now. I mean, we're seeing tons of it, and we've got a lot of electronics going on, and when there's a complication or what have you, it takes a little bit of time. But there's this new they call it SOVD, the software oriented vehicle diagnostics. So Bob Grzinski probably knows all about this, but it's the way that they're going to construct the car to help us and diagnose and understand what's going on around the vehicle, and have the software on the display screen, like the Tesla, that now becomes your scan tool. And it's amazing the data that it can bring back to you to show you illustrate what's going on with the car. So pretty cool.
Very cool.
Yeah.
Well, thank you everyone again. I want to remind you, upcoming months, next month, Adam Roberts, then Dave Hobbs in October, Craig Shippey, Jeff Zide, Robert Kenny in January 2024, and more stuff. And our big event in April, the first Saturday in April this year. So we want to thank you for all coming out. Thanks again, Scott Brown, and everyone who participated. We will see you next month.
And one last thing, since we're not going to see you before then, have a great Labor Day.
Oh, yes, that's right. Don't labor on your Labor Day.
You try not to anyway.
Thanks again from New York. I'm Cheech.
And I'm Pierre.
Thanks, Scott.
Thank you. Good night.
Yep. Good night.